Everyone thinks RAG is just search plus LLM. Throw documents into a vector database, retrieve top K chunks, and that's done. But that is a toy version. No one uses that kind of RAG in production. In the next 5 minutes, I'll show you what RAG actually looks like when you are serving real users. The technique nobody explains. Starting with basics, what is RAG? RAG is Retrieval-Augmented Generation. It exists simply because LLMs have two fundamental limits. Their knowledge is frozen at the training time and their context window is finite. So instead of retraining the model every time your data changes, you keep the model static and inject only relevant context at the query time. The LLM becomes a reasoning engine and your retrieval system becomes kind of its memory. Beat any RAG which you see, the Notion AI, Perplexity, GitHub Copilot Chat, all are variants of this pattern. But the gap between the RAG and the tutorial RAG which you see, it is enormous. Let me show you why. We'll talk about the pipeline of how RAG works, and then I'll talk about the problems which you face when you are building a RAG. So there are 5 stages to RAG. Let me walk through each of them. First, you've got to break your documents into small pieces. You cannot embed a 200-page PDF as one single thing. So you chop it up. But how will you chop it up? Here's where people screw up. They just slice every 500 tokens and call it a day. Now half your function definitions are split across 2 pieces. For example, the tables could be cut in half. The context between first half and second half, that is gone. Just cut at any place wherever you reach 500 tokens. You want to break the things at natural spots. Maybe at the end of a paragraph, at the end of a section. Stuff that's actually together should stay together. That's the first part, which is ingestion. Second part, you take each piece and turn it into a vector, basically a long list of numbers that represents what the text means. 2 pieces about database will have similar numbers. A piece about database and one about cooking, it won't have similar numbers. Which embedding model you pick, be it OpenAI, Cohere, one of the open source ones, it actually matters a lot. Different embedding models have different idea of what similar means, and you should actually see what embedding model fits your use. Third, you store these vectors somewhere where you can search them fast. For this, you can use any of the vector databases like Pinecone, BV8, pgvector, whatever. The catch is searching millions of vectors exactly is too slow. So these databases cheat a little. They use approximate search. So you give up maybe 1% accuracy, you get answers in 50 milliseconds instead of 5 seconds. Now the fourth part, the actual retrieval. User asks something. You embed this question again in a similar way like you embedded your documents. The database returns the closest chunk, usually up to 5 to 20 documents. Now the fifth and the final step. You take those chunks, paste them into a prompt with the original question, and then you send all of this to an LLM. The LLM reads the context and then finally gives you an answer. That's the whole pipeline of how RAG works. And it works great in tutorials, but there are a lot of issues in each of this and a lot of depth of why each of this can fail and why it dies in production. Problem 1. Retrieval is worse than you think. Vector search is good at meaning, but terrible at exact matches. For example, let's say user searches error code 403. Vector search returns stuff that's about errors, but it is useless. How do you fix this? Using hybrid search. You run vector search and old school keyword search together at the same time, and then you merge these results. Keyword search nails the exact match part, and the vector search nails the semantic stuff. What are errors? Those kind of things. But even then, your top 20 results are noisy. So you add a re-rank. Think of it kind of like a second pass, a smarter model that takes those 20 candidates and actually reads each one against the query, then scores them properly. One of the popular one is Cohere rank. It's slow per item, but you are only running it on 20 things, not 20 million. You go from 20 noisy chunks to 5 great ones. Now comes the second problem. People don't write queries like documents are written. Someone types, let's say, why is my deployment failing? Your docs say common causes of CI pipeline failures. They both are different things, and vector search is unable to find correlation between these. So how do you fix this? You fix this by transforming the query before you search. So how do you transform the query? First thing is query rewriting. Just ask the LLM to rephrase the question into something that sounds more like how the docs are written. You can use a cheap LLM for this all. Second thing, this one's clever. What do you do in this is that instead of searching with the question, you ask the LLM to write a fake answer first by just asking it to guess. Then use this fake answer to search. Now, why this helps? It is because the answers look more like the documents which you have stored. Now, whatever you're querying looks more like your documents and you can get a better match. The third thing is multi-query. So for this, what you do is you generate 4 different versions of questions and search with all of them. At the end, decide what are the good things which you want to give out. Now comes the third problem. You found too much stuff. For example, you found 20 relevant chunks and your context window gets overloaded. So now what will you do? So here you have two options. Either you compress, run each chunk through a small LLM that strips out the fluff and keeps only what's relevant to this specific query. Or the second thing is you go hierarchy. What I mean by that is that you create a multi-agent system. So first you find the right documents, then you find the right sections. Inside them, keep on finding. So basically you have to do this in layers. Now the fourth problem, you have no idea if your RAG is good. So most teams ship and pray that hope this RAG works. But you have to use something like RAGAS. But you have to measure two things here. Faithfulness. Is the answer actually based on the chunks that you retrieved, or did the model make stuff up? And second is relevance. Does the answer actually address what the user asked? You can have one without the other. An answer can be faithful to the docs, but completely misses the question. So you have to measure both of these things. Otherwise, you're just shooting in the dark. Now, how to build an architecture that actually ships. So when you put all of this, what we discussed together, real RAG looks nothing what the tutorial tells. You've got a router that decides if you even need a RAG, or it can go straight to LLM. You have a query rewriter before you are even performing the search. A hybrid search of making a query to RAG and also keyword search. Then a reranker, which ranks the output of the chunks and the documents which you get. And then compression to fit all of this into a context window. A prompt that forces citations so that the model says I don't know instead of making things up. And the final thing is you have evals running in the background checking that all the information is from the documents and they are answering what the user is asking. And under all of this, you also need logging to make sure that every query, every retrieval, every generation, how is it working? Because eventually your system is going to say something dumb at 3 a.m. and you need to know why it happened and you have to catch it first before your customers catch it. So the real takeaway from this is that retrieval is actually the hard part in RAG. It is not the generation. Generation is mostly solved. The LLM is a commodity now. Everyone is creating new LLMs, every new lab. So your pipeline is actually what you want. So start simple, how to building a RAG with a small tutorial, which I can build also in the next video. But know that every stage, chunking, embedding, retrieval, everything, all of these stages are important, equally important, and you have to tune all of these separately.